hovering by my suitcase, trying to find a warm place to spend the night. Yeah, baby. And a heavy rain falling, seems I hear your voice calling. It's alright.
Alright, let's finish section 3.1 on classifying polynomials. Today what we need to do is talk about like terms first of all. So what are like terms? Like terms contain the same variables raised to the same power. So first of all, let's look at some things which are like terms. Yes, all these things are like terms. Things like 5x squared and negative 2x squared. Those are like terms. They have the same variables, x, and those variables are raised to the same power, 2. 3m squared n to the 4th power, that's a 4, and m squared n to the 4th power. Those are raised to this. They have the same variables, m, n, and they're raised to the same power, 2, 4, 2, 4. One more, 2ab c squared d and 15ab c squared d. Those as well are like terms. Okay, here's some things which are not like terms. Let's go with the 5x squared again, just like we did here. If it was 5x squared and negative 2x, just like before, but not squared, those are not like terms. They have the same variable, x and x, but this one's raised to the 2nd power, this one's only raised to the 1st power. Doesn't work. 3m squared n to the 4th power, just like over here, but this time let's make it m squared n to the 4th power p. Yes, they both have m squared and they both have n to the 4th power, but this one has a p to the 1st power and there's no p over here. Have to be exactly the same in every way. And the last one, 2ab c squared d and 15abcd. We got all the same variables, abcd, but this c is squared and this one's not. They're not like terms. Alright, so now you know what like terms are. What we need to do is we need to combine these like terms. When we say combine like terms, we mean we're adding or subtracting them. And the way we do is we add or subtract the coefficient of the terms and keep the like terms the same. So you can only add and subtract like terms. Once we multiply and divide on the other side of the sheet, they don't have to be like terms. But adding and subtracting have to be like terms. And the other thing is you want to put them in your final answer in descending order of powers. And what that means is you're going to write them with the term with the largest degree is going to be written first, then the term with the next highest degree, and then the next highest degree, etc., etc. So for example, just an example of that, if we had these following terms, if we had 3x plus 2 minus 4x squared plus x cubed, let's say, and we wanted to write that in descending order of powers, you'd look at the degrees of each of these. What are the degrees? 1, 0, 2, 3. Oh, so the first one would be the x cubed. That's the highest degree right here. You look at the sign in front, if it's a positive, so it's positive x cubed, or just x cubed. Next is this one, negative, so minus 4x squared. Next one is the first one out front. It's a positive sign out front because you don't see any sign, so it's positive 3x. And finally it's plus 2. This is now written in descending order of powers. Okay, so let's do this. We're going to combine like terms here. So there's two ways you could do this. One way is you could rewrite the things that are like terms side by side. So for example, I see a 5m squared here. Now what could I combine that with? Well, it has to be another m squared, and I see another m squared here. So I'm going to rewrite that and make sure to include the sign in front of it. So minus 3m squared. Now come back to here. We have a plus 2m. Do we have a like term for the 2m? Yep, this is a like term. So minus 4m. So you can do it that way. Or the other way, which I usually do, and it's a little bit faster, is I just use like different underlinings. So I take a look at the first one, 5m squared. What's the like term with 5m squared? This one is, and I underline including the sign in front. So I have 5m squared minus 3m squared, which is 2m squared, right? Subtract the coefficients, 5 minus 3, and keep the m squared the same. And then I look for another like term. I have this positive 2m, notice I underline the sign, and I also have a minus 4m. I'll do a different underline style so I don't get confused. So I have positive 2m, take away 4m. So positive 2 take away 4 is negative 2, and then I keep the m the same. If you're going to do it finishing off, this method here will of course give you the same answer. 5m squared minus 3m squared is 2m squared. There it is. Plus 2m take away 4m is negative 2m. So it's done. Okay, either one of those methods are fine. I imagine many of you are going to go with my method of underlining. Why do I know that? Because it's faster. But it's up to you. Okay, I'll do both methods again. The first thing I see here is 2mn. Is there any like terms with the mn? Yes, there's one right there. So include the sign in front of it, minus 3mn. Okay, I'll go back and write this one down, the negative 4m squared n. Is there a like term for that? Yes, right there, negative 6m squared n. And then I have a plus m3. And then you could write down your answer. But let's do it the other way as well. Underline the first one. Where's my like term with that one? Here, and I underline the sign as well. Then I do a different type of underline, including the sign in front. And the like term with that one is this one, including the line and the sign in front. And then maybe I'll do like a double underline for that one, just so I can separate them all. So 2mn take away 3mn, just like it says here, 2mn take away 3mn. So we subtract the coefficients. 2 minus 3 is negative 1, and keep the mn the same. So negative 1mn, but you don't have to put negative 1mn, you can just put negative mn. If you put negative 1mn, that's fine. I'm not going to take marks off for that. Okay, now the zigzag line, negative 4m squared n, take away 6m squared n. So we do negative 4 take away 6, or if you're looking right here, negative 4 take away negative 4 take away 6 is negative 10, and keep the m squared n the same. Keep the like terms the same. And finally, there's also this double underlined plus m cubed. So that's your answer. Okay, one more of these. This one's a little tricky. What we have here is negative 2/3 x squared, and the like term with that is this plus 1/2 x squared. Then we have plus root 24 and minus 2 root 54. These are like terms because there's no variables in those. They're just constants. And so constants are like terms with one another. Alright, so we can combine these first two terms. We can keep the x squared the same, and we have to add the coefficients. Adding fractions. What do you know about adding fractions? You need a common denominator. What's the common denominator of 3 and 2? 6. So put it over 6. What do you multiply 3 by to get 6? 2. Do the same to the numerator. You get negative 4 over 6 x squared plus 1/2 is the same as 3/6 x squared, right? Multiply the bottom by 3, top by 3. 1 times 3 is 3. Plus, now we have radicals here. Remember adding radicals? You want to put it in simplest radical form. How are you going to do that? You're going to do the tree, the factor tree. So 24, let's break it down. Pick a couple numbers. How about, I don't know, 6 and 4, 8 and 3, whatever you want. 6 can be broken down into 2 and 3. 4 can be broken down into 2 and 2. What are we looking for here? We are looking for, since it's club 2, there's a little 2 there, we need a pair. Well, here's a pair here, so that can move out front. So we have 2 out front. What's left in? 2 and 3. Multiply them together, 2 times 3, we get 6. So root 24 is the same as 2 root 6. Take away, now we do the same thing. Let's do a tree for 54. 54 could be 9 and 6, and then 9 could be 3 and 3, and 6 could be 3 and 2. Again, it's club 2, so we need to circle a pair. There it is. A 3 comes out front, but there's already a 2 there. So remember, a 3 comes out front and multiplies by that 2, you get 6 out front. And what's left inside is 3 times 2, which is 6. Okay, now we're good to go. So the first two terms we can combine. We have to add negative 4 over 6 plus 3 over 6, which is negative 1 over 6 x squared, plus 2 root 6, take away 6 root 6, is negative 4 root 6. I guess I shouldn't have put that plus sign, should I? You could put plus negative, but we'd rather just put minus. Positive 2 root 6, take away 6 root 6 is 4 root 6. This is fine. You could have it like this, or the other thing you could do is you could move this x squared into the numerator position, so you'd have negative x squared over 6. You don't need the 1 anymore. Take away 4 root 6. This would be the easiest way to write it. Okay, good. That's how you combine like terms. Now, we're going to start multiplying. You do not need like terms when you multiply and divide polynomials. So the first thing we're going to do is multiply one monomial by another monomial. Remember, monomial is just one term by another one term. Monomial by monomial. How do you do that? First of all, you multiply the constant factors together, and then you multiply the variable factors together. So you probably won't need to write this down this way, but just to show you how you do this. Okay, because with multiplication, order doesn't matter, we could pick what we want to multiply. So we could multiply 5 times, let's multiply it by the other coefficient, negative 4. Then we can multiply it by this m squared, and then we could multiply that by the m to the 4th power. Now the reason we do it like this, why we've rearranged it, because now you can just multiply those two things together and multiply those two things together and you'll get your answer. So 5 times negative 4 is negative 20, and m squared times n to the 4th. If you have the same base and you're multiplying, what do you do with the exponents? You add them. So negative 20 m to the 6 is your final answer. Now you probably don't need to write this all out, do you? You could just look and say, okay, I'm going to multiply 5 times negative 4, which is negative 20. M squared times m to the 4th is m to the 6th, like that. But I'll keep doing it like this, just so we're crystal clear. In this one, we'd multiply negative 3 times the negative 5. You'd be multiplying x squared times x cubed. Just write everything next to the similar terms. The coefficients beside each other, the x terms beside each other, the y terms beside each other. So that's what I'm doing right now. Y times this y, and then we have one z over here. And then we multiply all that. Negative 3 times negative 5 is 15. X squared times x cubed, add the exponents, you get x to the 5th. Y to the 1st power times y to the 1st power, add those exponents, get y squared. And you still have a z. You have to write it down. There you go, there's your answer. Next one, we'd multiply 6 times 1, but there's no point in doing that, times negative 2 times x squared times, what does that say, x to the 5th times y cubed times y to the 7th. Again, you don't have to write all this out. If you're saying, I could do that without, go ahead, don't write it out. I'm fine with that. You could just go right away. 6 times negative 2 equals x times x squared times x to the 5th equals. I'm just trying to show you in case you're not getting the concept. 6 times negative 2 is negative 12. X times x squared times x to the 5th. You have to add all the exponents. So you're adding this 1 plus 2 plus 5. That's x to the 8th. Y to the 1 times y cubed times y 7th. Add all those together, you get y to the 11th. And you're done. Okay, the next title in your book is Multiplying a Polynomial by a Binomial. So I wrote it down here as well, so you could reference the textbook or workbook if you have to. I kind of wonder if they made a mistake. It's not the clearest name. I would actually call it Multiplying a Monomial by a Polynomial, because to me that's more what it is. You've got a monomial up front, a monomial up front, monomial up front, and you're multiplying it by a binomial in this case, a binomial, trinomial here. So I think this might be a better title. But anyway, regardless, you're going to pick up the pattern. So how do you do this? Use the distributive property. It's also called expanding, right? Expand this. But if you've ever been in my class before, you know that what I call this is mountains. Why do I call this mountains? Because when you multiply, you're going to multiply this monomial up front is going to multiply by this term, and it's also going to multiply by this term. And come on, you can't tell me that those don't look like beautiful, gorgeous mountains with the sun coming up through the middle. Oh, look at that, it's beautiful. Oh, what's this up here? A couple birds flying by. Isn't that beautiful? So these are the mountains of multiplication, I call them, because that is how you solve all these sorts of questions. You multiply these mountains. So it's hard to see here, but there's actually squared there, as you can see on your worksheet. So 5 times 3 is 15. M squared times m, add those exponents, and you'll get m cubed, and there's still an n there. And then for the second term, the second mountain, it's 5 times negative 2, which is negative 10. m squared times m cubed, add the 2 and the 3, and you get an exponent of 5. And there's no n's in this case, so this is it. Your final answer is 15m cubed n minus 10m to the 5th. Alright, next one. We have our monomial here, and we're going to have to draw two mountains again. So, first mountain, negative 3 times 4 is negative 12. X squared times x cubed is x to the 5th. Add the 2 and the 3, right? Y times y squared is y cubed if we add the exponents. Next mountain, negative 3 times negative 1 is positive 3. X squared times, oh, there is no x here, so it just stays as x squared. Y times y to the 3rd power is y to the 4th power. And then we still have a z. That's it. Last one. Okay, we have three different polynomials here. We have a monomial, and we have a trinomial. Three things you're multiplying. Remember, when you multiply, order doesn't matter. So you could multiply the first thing and the second thing, and then multiply that answer by the third one. Or if you want, you could multiply the second and third first, then multiply that by the first. Whatever. But I think it is easier to multiply the first two things first, these two monomials. So let's do that to start. A times a to the 4th is a to the 5th. B to the 3rd times b to the 3rd is b to the 6th, just adding exponents, right? And then we're going to multiply that monomial by this trinomial. Negative a cubed b minus a squared plus a to the 5th b to the 5th. And we're going to have to do some mountains. How many mountains this time? 3. One here, one to there, one to there. Okay, here we go. We have a positive times a negative, so it's going to be negative. A to the 5th times a to the 3rd, add the 5 and the 3, get 8. B to the 6th times b to the 1 is b to the 7th. Now for the second mountain, we have a positive times a negative, so it's going to be negative. A to the 5th times a squared is a to the 7th. B to the 6th just stays the same. Third mountain, a positive times a positive is a positive. A to the 5th times a to the 5th is a to the 10th. And b to the 6th times b to the 5th is b to the 11th. Add those exponents, the 6 and the 5. This is our answer here. There you go. I hope a lot of that seemed somewhat familiar to you. Make sure you learn it. It's important stuff. And good day to you.
A rainy night in Georgia. Said a rainy night in Georgia. Lord, it's just raining all over the world, baby. That's the way I feel tonight. It's raining all